when we are scoring in our game of Scrabble, well, we should probably abide by kind of the core rules of Scrabble for scoring. And that is, regardless of the board, we're going to take each letter, map each of these letters to a specific numeric value, and then sum all of those up. So let's go ahead, we'll grab the code that we are working with so far, and we'll move to our next cell. And in this case, I want to add a little bit of the rules for scoring. So let's call this scoring here. So we have a function that gets the count of each letters. We have a function that will find all of our potential candidates. And now we want to figure out how to score these things. So since we're already writing functions, maybe I'll write kind of a template here just to say I'm going to need to score these. Now the question is, what are the inputs and what are the outputs? Before I get too deep into the function, we need to figure out, well, what are the current point assignments for each of our letters? Since this is on a per letter basis, well, we could have some type of mappable object, maybe like a dictionary, mapping each letter to its point value. As for what those values will be, well, let's refer, of course, to the Scrabble documentation, and I say documentation from a programmatic perspective, but here we see we have a couple pieces of very important information. We have how many letters appear in the game of Scrabble, and then of course we have their point values. Now these point values are going to be what I'm interested in, and we'll see if we can incorporate these into our code. So let's go ahead and we'll create just a quick cell here to work with this text in. Now I could use my editor to figure out or to grab each of these point values, but remember I'm trying to build a dictionary here. And so I think the easiest thing that I could do is I'm going to go ahead and get rid of all of this extra text here, and we'll see how quickly we can dial this down. So this is my text. I'll just use triple lines for a multi-line string here. We'll strip this for line and text.split lines. And remember, each line is going to be indicative here of how many points these are worth. So we have our print line. That looks good, and this should be a single line with no S. Okay, so we have our lines. Now the next thing we want to do here is I'll want to extract the numeric value from the left-hand side as well as the letters from the right-hand side. We can use our string partition method to do this pretty easily. So we'll call this value, comma, let's say underscore for the separator, and then letters is equal to line dot partition. And we'll just split this on the hyphen here because we can always separate each of these pieces. So I'll need to say value is equal to the int version of itself. And then my letters, we'll need to split this into a collection. We'll say letters.strip.split on a comma and a space. And then we'll go ahead and of course print out our values and each of the letters. We are almost there. Now we'll lowercase each of these letters as well, but the last thing that I'll need to build here is a points dictionary, just like this. And then we'll just say points of each letter. So we'll probably say, do an inner for loop here for L in each of these cleaned up letters. The points for the current letter is equal to the value. Just like that. And there we go. We have a single point mapped to each of these letters. I can of course move this int down here, but this is how I would just kind of quickly scrape these letters. Now what I would do here is I'll grab this line of code since the representation is equal to the structure here, and I would define this as some type of constant. So this would be my points. And of course we would paste this in just like that. Now I'll go ahead and clean up just so we don't have a single very long line. And then we'll be on track to start mapping these letters here. Now, one thing that may help me in the future, you can see that these letters are not ordered by their position in the alphabet. It's actually ordered, I believe, by points. So we have all our 1s and then our 2s, 3s, 4s, and 10s. I could have, of course, created a dictionary from the sorted elements here. And that would have given me A through Z all in order. But I think for the most part, ordering is not going to be something super important just for my own eyes. So now that we have some context or some idea of what our points are, I'm going to want to figure out, well, how can I actually create a score for each of these possible candidates? So we'll say this, my candidates is equal to this list of values here, and I'll print those out just to remind us what's in here. Of course, we'll comment that out for now. So we have Python and think. Now what I'll do is for each candidate or each C in candidates, we need to figure out how to score each of these parts, each of these things. So the current score, we'll just start it at 0, and we'll iterate over each letter. For letter in C, now we can use our points system as a lookup. And this actually gets us to a very interesting question. If I take my points and I look up a given letter, I'm expecting to get a score back out. But you can see here, well, what's going on with the letter P? So maybe we don't have the letter P available to us. Or we can note that our points are all capitalized. And so one thing that I might want to do is I might want to just redefine this in my dictionary here. And so we'll say key.casefold here to the value for k, v and points.items. And then now we have each of our letters. Since our letters are all lowercase to begin with, we actually have a mapping here of each letter and how much they are worth. Now, of course, we can take our current score and just increment it by the score of each letter. Something like this. And then we know the score for each of our words. So I'll print out the current word we're looking at, the current candidate, I should say, as well as the score. So in this case, Python scores 14 points, whereas think scores 15 points. And so if we take this code here and we think, okay, well, how would I then select Python as my play over something like think just based on the points? Well, one thing that we might do is I might take each of these candidates and score them and then take the maximum score, the one that's associated with the maximum score. I could do something a little clumsy like this, candidates and scores, create an empty list, and then say candidates and scores dot append, just like that, and we'll append a tuple here, so append the candidates as well as the cur score. Now we can look at my candidates and scores here. And then I could print the maximum one, and of course we would need a key here, just to take the max based on our value. So that's the max candidates and scores there. Just making sure. Looks like a small speller. Okay, so this gives us our Python value back out. Now this does feel quite clunky. So let's go ahead and revisit the code that we've written and see if we can write this maybe a little bit better. And I think one very interesting point that comes up when we rewrite this, let's go ahead and get that rewritten. throw this in our score function. Now, this will take, of course, some word here, and then we're going to return, right, that current score that we defined earlier. So I'll take all of these values, or this portion here, and throw it up here. Now we can return our current score. There is a very large assumption, two assumptions I've baked into this function though that I don't know if I love. One, I'm going to assume that we always want to use this globally spaced points dictionary. Well, what if I want to play, or my client wants to play with some different set of points? What if we don't love that Q and Z are the only two tiles worth 10 points, and we want to say, you know what, W doesn't come up as often as I would like it to, and I want W to be worth more points. Well, then instead of modifying a single global variate, I might do something like this. I could say my points is equal to points.copy, just like this. And then I could say something like my points W is equal to 10. Alternatively, I could use the new dictionary merge operator. So I could do something like this. My points is equal to points, and then I'm going to merge in my replacements like this. This gives me a nice copy as well. And so if I did this, how would I actually get my scoring function to use these points? Well, one thing I could do, instead of always relying on a global variable, I could just have the points dictionary be something that's passed in to this game. And from here, we can actually make sense of this function. There's a couple of other thoughts that come to mind as well. Instead of having points be passed in every single time that I call score, I could have score, or I could have some type of decorator type pattern where I bind, right, my points dictionary onto the score function itself. And that way you just need to set up your scoring system once and then you can forget about it. And so we might take that path in the future, but for now I think just passing in our points as another argument will get us a good deal of the way there. Now, we are also making one other assumption. We're assuming that every single letter I'm going to encounter in any given word is going to be present in this points dictionary. And if I want to relax that constraint, I need to figure out what to do if I have undefined values or keys that map to undefined point values. And so from there, I might say, well, if a key is not defined, maybe it just has a point value of 0. And here I can use .get and then bring up 0. The issue with using .get here is if somebody feeds in a word, right, all I'm doing to define the protocol of this word, it has to be iterable. So I could, in theory, pass in a list. And that list could have nonsense in it. It could have things that are not letters in it, and then I'm just assigning those a 0-based value. When in reality, maybe I should be raising some type of key error to let the end user know that you've tried to feed in something to this function that simply does not work. Now, I would probably let the end user define that behavior. So I'll go back and pick this up and say, well, here's our scoring policy, right? We have these points. You're the one feeding in what these points are worth. I'm just eliminating some of the boilerplate code. If you have a letter that doesn't exist in your points dictionary, well, you should catch that as a key error and you should do something manual with it. And so that's one of the approaches that we could take here. Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.